March 15, 1967. 4:30 a.m. A Lockheed C-130. A Hercules sits on the ramp at Da Nang Air Base, Republic of Vietnam. The aircraft tail number 56-0509. United States Air Force Tactical Airlift Mission to Khe Sanh Combat Base. Technical Sergeant David Morrison supervises cargo loading through the rear ramp. Pallets of ammunition, medical supplies, and rations move into the cargo compartment on rollers built into the floor, each pallet secured with chains and tie-down straps. The C-130 can carry 25,000 pounds of cargo, or 92 combat-equipped troops. Captain James Wheeler completes his exterior inspection, walking beneath the high wing, examining the 4 Allison T-56A-15 turboprop engines. Each engine produces 4,250 equivalent shaft horsepower. Each drives a 13-foot 6-inch diameter 4-blade propeller. First Officer Lieutenant Robert Hayes checks the landing gear. The main gear retracts into external fairings along the fuselage sides. The nose gear folds forward into the fuselage. Simple, rugged. Designed for operations from unprepared airstrips. Flight Engineer Staff Sergeant Paul Brennan inspects hydraulic lines, control cables, and fuel quantity. The C-130A carries 9,000 gallons of fuel in integral wing tanks. Range, approximately 2,000 nautical miles depending on payload and altitude. The loadmaster's domain, inside the cargo compartment, Morrison directs the final positioning of pallets. The C-130's cargo floor measures 41 feet long, 9 feet wide, and can support concentrated loads that would buckle the floors of commercial transports. The rear ramp measures 10 feet wide. When lowered, it provides direct ground-level access for vehicles, artillery pieces, and palletized cargo. When raised and sealed, it forms the aft pressure bulkhead. The C-130 is pressurized. Cabin altitude maintained at 8,000 feet, while cruising at 25,000 feet. Troops and crew can operate in relative comfort at altitudes that would require oxygen in unpressurized aircraft. Morrison secures the last pallet. Total payload today, 18,000 pounds. Well within limits. Cockpit preparation Wheeler and Hayes climb the crew entrance door on the port side, forward of the wing. The cockpit sits high above the ground, the high wing configuration providing propeller ground clearance and allowing the fuselage to sit low for easier cargo loading. The instrument panel extends across both pilot positions. Airspeed indicator, dual altimeters, vertical speed indicator, artificial horizon, heading indicator. Engine instruments clustered for both pilots and flight engineer to monitor. Brennan occupies the flight engineer's station behind and between the pilots, facing a panel of fuel system controls, electrical systems, hydraulic pressure gauges, and engine monitoring instruments. The checklist begins. Battery on. External power connected. Fuel panel configuration. Hydraulic systems, check. Flight controls. Full deflection check of ailerons, elevators, and rudder. The Allison turboprops. Each T-56 engine represents mature turboprop technology. A gas turbine core driving a reduction gearbox that turns the propeller at a fraction of turbine shaft speed. The combination provides jet engine power with propeller efficiency, ideal for tactical airlift, requiring both speed and short-field performance. Brennan initiates the start sequence for engine number 3. Inboard starboard. The procedure is methodical, precise. Ignition on. Starter engaged. Fuel flow initiated. The propeller begins to turn. The turbine spins up, compressing air, igniting fuel, accelerating toward idle speed. The sound builds, a rising whine that settles into the characteristic turboprop hum. Engines 4, 2, and 1 follow in sequence. 4 T-56 turboprops now running, generating 17,000 equivalent shaft horsepower, ready to move 65,000 pounds of aircraft and cargo into the air. Ground operations. Outside, ground crew remove wheel chocks and disconnect ground power. The C-130 is self-sufficient now. Auxiliary power unit providing electrical and pneumatic power if needed, though the running engines supply all necessary services. Wheeler receives taxi clearance from Da Nang Tower. The C-130 begins to move, its nose wheel steering responsive, its high wing providing excellent visibility for ground operations. The engines respond smoothly to throttle inputs. Turboprops offer precise power control compared to piston engines. At the runway hold point, Brennan completes the before takeoff checklist. Flaps, 50%. Trim, set for takeoff. Propellers, full forward pitch. Flight controls, checked and free. Takeoff performance. The C-130A requires approximately 105 knots for rotation at current weight. Wheeler calculates the figures based on temperature, pressure, altitude, and gross weight. Da Nang's runway is adequate, 10,000 feet of concrete, though the C-130 was designed to operate from runways as short as 3,000 feet when lightly loaded. Tower clears the flight for takeoff. Wheeler advances all 4 power levers. Brennan monitors torque meters, each engine developing maximum allowable torque for takeoff. The C-130 accelerates rapidly despite its size, 80 knots, 90 knots, 100 knots. Hayes calls speeds. Wheeler maintains directional control with rudder and nose wheel steering. Rotate. Wheeler applies back pressure. The nose lifts. The main gear remains on the runway briefly, then the wings generate sufficient lift. The C-130 climbs at 1,500 feet per minute. Gear retraction. Hayes raises the landing gear handle. The main trucks swing inward and upward into the fuselage fairings. The nose gear folds forward. Clean configuration. Departure and climb. The C-130 climbs northwest from Da Nang, following the valley corridor toward the highlands. The flight plan calls for cruise at 25,000 feet, though the aircraft will descend for the tactical approach into Khe Sanh. At 10,000 feet, Wheeler levels briefly for flap retraction. The flaps fold upward in stages as airspeed increases. Clean configuration at 160 knots. The C-130 continues climbing. Brennan manages engine power, adjusting propeller RPM and torque to maintain optimal climb performance. The turboprops are fuel efficient compared to pure jets, burning approximately 1,000 gallons per hour total across all 4 engines at cruise. Design origins. Lockheed began designing the C-130 in 1951, responding to a U.S. Air Force requirement for a tactical airlifter capable of operating from unprepared airstrips while carrying substantial cargo loads over medium ranges. The design team chose a high wing configuration for several critical reasons. The high wing kept the fuselage low for cargo loading. It provided propeller clearance on rough fields. It placed the engines above dust and debris kicked up during operations from dirt strips. 4 engines provided redundancy and power. Turboprops offered better fuel efficiency than jets at tactical airlift speeds and altitudes. The rear loading ramp allowed drive-on, drive-off loading of vehicles and equipment, revolutionary for the era. The first YC-130 prototype flew on August 23, 1954. Testing proved the design sound. Production began immediately. Early service. The C-130A entered operational service with Tactical Air Command in December 1956. Initial operations revealed minor issues. All new aircraft types require refinement, but the fundamental design proved robust. The C-130B followed in 1959 with improved engines and increased fuel capacity. The C-130E came in 1962 with additional fuel in external tanks and increased maximum gross weight. Each variant improved on the basic design without changing its fundamental character. Flight to Khe Sanh. At 25,000 feet, Wheeler levels the aircraft. Brennan reduces power to cruise settings. The C-130 settles into efficient flight at 250 knots true airspeed. The navigator, seated at a station in the cargo compartment's forward section, monitors position using radio navigation aids and dead reckoning. The flight to Khe Sanh will take 45 minutes. Below, the Vietnamese highlands stretch in patterns of jungle and mountain ridges. The weather is clear today. Visibility unlimited, scattered clouds at lower altitudes. Wheeler engages the autopilot. The system maintains heading and altitude, though the crew remains actively engaged, monitoring instruments and systems. Tactical descent. 30 miles from Khe Sanh, Wheeler begins descent. The tactical approach requires rapid descent to minimize exposure time. The C-130 descends at 3,000 feet per minute, trading altitude for speed. Brennan monitors engine temperatures during the descent. Rapid power reductions can shock cool turbine components, so he manages the descent carefully, maintaining adequate power to protect the engines while descending quickly. At 5,000 feet, Wheeler levels briefly, configuring the aircraft for landing. Flaps extend. Landing gear lowers. 3 green lights confirming nose and main gear locked down. Khe Sanh appears ahead. The runway is 3,900 feet long, pierced steel planking laid over red clay. The C-130 can operate from this runway comfortably. Tactical landing Wheeler flies the visual approach, descending rapidly toward the threshold. The C-130's handling is precise despite its size. Responsive controls, stable flight characteristics. The threshold passes. Wheeler reduces power, initiating the flare. The main gear contacts the pierced steel planking. The nose gear settles. Reverse thrust on all 4 propellers provides powerful braking force. The C-130 decelerates rapidly, stopping within 3,000 feet. Ground direction guides the aircraft to the unloading area. Wheeler keeps the engines running. This will be a rapid turnaround, cargo off, aircraft out. Cargo operations. Morrison lowers the rear ramp. Ground troops board the aircraft, begin removing pallets. The entire unloading process takes 12 minutes. Empty now, the C-130 will depart immediately. Minimum ground time reduces vulnerability. Wheeler receives clearance for immediate takeoff. The C-130 taxis directly to the runway, completes abbreviated checks, and departs. The lightly loaded aircraft climbs steeply, turning south toward Da Nang. Evolution and variants. Over 7 decades, the C-130 evolved into numerous variants. The C-130H introduced upgraded engines in 1974. The T-56A15 replaced by more powerful variants. The C-130J Super Hercules arrived in 1999 with new engines, 6-blade propellers, and digital avionics. Special mission variants proliferated. The AC-130 gunship, the EC-130 for electronic warfare, the HC-130 for combat search and rescue, the KC-130 tanker, the MC-130 for special operations, weather reconnaissance, firefighting, scientific research, Antarctic supply missions. The basic airframe proved adaptable to countless roles. Global operations. By 2025, over 70 nations operate C-130s in various configurations. The aircraft serves in climates ranging from Arctic to tropical. It operates from paved runways at sea level and from gravel strips at high altitude. The C-130 lands on aircraft carriers during tests. It lands on ice in Antarctica. It delivers supplies to remote Pacific islands. It performs humanitarian relief after natural disasters. The versatility derives from fundamental design decisions made in the early 1950s, decisions that remain sound 70 years later. The cockpit experience. Flying the C-130 requires active piloting. The flight controls are hydraulically boosted but retain mechanical backup. If hydraulics fail, the crew can still control the aircraft through direct cable linkage, though forces are higher. The 4 throttles require coordination. Engine synchronization is critical. 4 turboprops running at slightly different speeds create uncomfortable vibration. The flight engineer manages this continuously. Fuel management is complex. Multiple tanks require balancing to maintain proper center of gravity. The engineer transfers fuel throughout the flight, ensuring optimal aircraft balance. Maintenance philosophy. The C-130's longevity derives partly from robust design and partly from systematic maintenance. Components are designed for replacement. Engines can be changed in hours. Wing sections can be replaced. Fuselages can be rebuilt. Some C-130's flying today were built in the 1960s. They've accumulated over 40,000 flight hours. They've been updated with new avionics, engines, and systems, but the basic airframe remains sound. This is intentional. Lockheed designed the structure with substantial margins. Load factors, fatigue life, corrosion resistance, all engineered conservatively. Return to Da Nang. Wheeler lands the empty C-130 back at Da Nang 90 minutes after departure. The mission is complete. Another will begin tomorrow, and the day after, and every day. In 1967, C-130's fly continuous missions throughout Southeast Asia. Cargo transport, troop movement, aeromedical evacuation, psychological operations. The aircraft proves invaluable for tactical airlift in a conflict characterized by dispersed operations and limited ground infrastructure. The mission continues. 58 years after that morning at Da Nang, C-130's still fly tactical airlift missions. The aircraft type that first flew in 1954 remains in production in 2025, the longest continuous military aircraft production run in history. The C-130J Super Hercules represents the latest evolution. More powerful engines, advanced avionics, improved performance. But the fundamental configuration remains unchanged. High wing, 4 turboprops, rear loading ramp. Because the original design solved the tactical airlift problem so completely that no fundamentally different solution has proven superior. Evening at Da Nang. The sun sets over Da Nang as Wheeler and his crew complete their mission paperwork. Tomorrow, another C-130 will fly the same mission to Khe-Sanh. Different crew, same aircraft type, same mission profile. This is the C-130's nature. Not dramatic, not revolutionary after its initial appearance. Just reliable, consistent performance of essential military airlift missions. The enduring design, 70 years of operational service. Over 2,500 aircraft built. Operations in every climate zone on Earth. Missions ranging from combat assault to Antarctic resupply. The C-130 Hercules doesn't represent technological sophistication or cutting-edge performance. It represents something more fundamental, a design that matches requirements so precisely that it remains relevant across 7 decades of technological change. The aircraft that made tactical airlift routine while remaining in service long enough to become history while still being present.